All right, guys, here we go again. If you are in Mrs. Bogenreit's class today, you're going to be taking some notes on IP 40.
And if you're in Mrs. Brown's class, it will be IP 33.
So you're going to title your page, whether it's IP 33 or IP 40. You're going to title your page Lewis dot structures. So there was a man a number of years ago, last name Lewis, that came up with a way to show how many valence electrons an atom has. If you're in my class, we already discussed what a valence electron is. If you're in Mrs. Brown's class, let her explain to you.
Valence electrons are the electrons on the outermost shell when you're drawing a Bohr diagram for an element.
So here's an example. This is an example of sodium, Na, drawn as a Bohr diagram. You'll notice that the first shell of electrons is full, 1, 2. The second shell of electron filled up with 8. But sodium actually has 11 electrons, so there's one more that would go on the outermost shell. That single electron right out here on the most outside is called the valence electron. So you guys need to take a couple of notes about this, about a valence electron. Maybe draw yourself a little picture. And the Lewis dot structure is a way to show how many valence electrons each atom has. It's actually pretty simple. It's just a diagram that includes the name or the symbol of the element with one dot representing that valence electron.
So if we use a capital E for a generic element symbol, remember the symbols for elements are either one capital letter or one capital and one lowercase, so we're going to use a capital E. If the atom has one valence electron, then we put a dot on the right side of the element symbol. If the element has two valence electrons, the next dot goes on the top. In other words, we are moving in a counterclockwise direction. So each time you add another dot, you move counterclockwise and then you double up when you get back to the right side of the element symbol.
So this is something that needs to go in your notes. The first valence electron would be here on the right, 2, 3, 4, and then like Mrs. Brown said, you would double up 5, 6, 7, and 8. And in this case, you're not going to be drawing any structures with an atom that has more than 8 valence electrons.
So if you completed the drawing atoms page, if you're in Mrs. Brown's class, you can use this as a reference to see the Bohr diagrams. And from the Bohr diagrams, you will be able to see how many electrons are in the outermost shell. You'll be able to see those valence electrons.
And if you're in my class, you guys can use this page where we use the Bohr diagrams, and we actually already figured out how many valence electrons, remember those are the electrons on the outermost shell, are in each atom. So use this as a reference, and if you've already done this page if you're in my class, or done this page if you're in Mrs. Brown's class, then today's assignment should be pretty easy.
So here is the page that you're going to complete today. It will be on OP 33 if you're in Mrs. Brown's class.
OP 33 if you're in Mrs. Brown's class, OP 40 if you're in Mrs. Bogenreit's class. So if we refer to the two papers that you guys did, we're going to take a look at, there's hydrogen here, or there's also hydrogen here. You'll notice that since hydrogen only has one electron, that means it only has one valence electron. So how we would draw it on OP 40 or OP 33 is one valence electron, hydrogen, gets one dot.
Then moving on over to helium, which is element number 2. Helium has 2 electrons total, and those electrons occupy the same electron shell, so they are the valence electrons for helium. That means helium has 2 valence electrons, and we put our dot, first one on the right and the second one moving counterclockwise, so it is on the top of the element symbol.
Coming back over to lithium, element with atomic number 3. If you refer back to your work, You can also use anything that you need to on your notes page to sketch these diagrams. If you are in Mrs. Brown's class and you don't have one of them, you can sketch anything that you need. Again, so we're looking at lithium. Lithium has one valence electron on its outermost shell. So again, I'm going to put one dot here. One thing that you're going to find as you're going through all of these elements is that there is a pattern to the valence electrons that are in each column. For example, everything in column number 1 you're going to find has one valence electron. All of the elements in column number 2 has two valence electrons. We're going to skip this middle section, which are called the transition metals, because they get a little bit weird right in here. Everything in this column has 3 electrons, and then moving over, helium is going to be a little bit weird. It has 2, where everything else here has 8 valence electrons. And here's just another diagram again to show you how these elements are related to each other. If it's all in the same column, then that means that they have something about them that makes them similar to one another.
And this is going to be important when we talk about how elements combine with other elements to make compounds, because this has to do with the valence electrons, and some elements cannot combine with each other. All of the chemical bonding and the chemical reactions have to do with their electrons.
So what you guys are going to do is you're probably going to be going back and forth between your OP and IP page. You're going to work to finish this worksheet for Lewis structures and also making additional notes that you need to on your IP side. And then we'll be checking it tomorrow. Have a good day.